I'm now calling Giuseppe Quaranta from Politecnico di Milano for the last presentation of the session.
Thank you, Clement, and thank you, everybody, ladies and gentlemen, for being here for this last presentation of this symposium. So I will take the opportunity to thank EASA for organizing this conference. It has been very interesting, so I hope you will find also interesting this last presentation. So today I will talk about this project that is called RoCS, Rotorcraft Certification by Simulation. I'm the coordinator of the project. I come from Politecnico di Milano, and I will introduce you to this Clean Sky 2 project. So we just started, so this is really an introduction. We haven't completed the project, but this is really an introduction to try to get more feedback on the work we are going to do. So this is the agenda for today. I will start briefing you about the objectives of the project. Then I will present the approach we want to pursue, the potential gains and challenges that are related to using simulations for certification. Then a few words about predictive fidelity and perceptual fidelities that are the two major elements to tackle in order to obtain a correct flight simulation. Then the expected impact of the project, and a few words about planned disseminations, where we expect all stakeholders to participate. Then I will go to the closing remarks. So what is the goal of RoCS? The goal is to produce a set of consolidated guidelines agreed with the certification authority. In this case, the certification authority is EASA, and applicable to helicopters and tilt rotors, to extend and facilitate a standardized application of flight simulation. So we are talking about simulation for flight and certification, the part of certification that is performed in flight. Of course, for the future certifications in Europe. And the goal is really to give the applicants to opt for simulation as a mean of compliance based on an equivalent level of risk with respect to the usage of flight test. So I should probably clarify what we mean by an equivalent level of risk, because it could be quite misleading. So for us, the risk is the probability of failure of a correct compliance demonstration times the consequences of this failing of no correct demonstration. So if we can bring the simulation up to the same level of a flight test, having the same level of risk, we will be successful in increasing the number of applicants that will use simulation instead of flight tests to certify at least portions of the certification activity of the aircraft. Of course, that will mean that the level of substantiation of the simulation to flight correlation should be commensurate with the level of compliance, meaning that the closer we are to being non-compliant, the higher should be the fidelity of the simulation. So this would really bring the risk to zero, possibly. But of course, this is a great challenge, of course, to be achieved. So this is a flowchart that shows the approach we want to follow. So we will start by going through the CS, so the certification standards, trying to identify what are the sections that could be tackled by simulation instead of using flight test. Then if we see that simulation is a possible mean of compliance, we will try to evaluate on one side the models, and so try to understand what is the right metrics to measure the fidelity of the model of the helicopter. And on the other side, we will work on selecting what is the right flight simulator to be used in order to achieve the goal. And so to define a metrics also for the fidelity of the cues in the flight simulator. Then we will have to develop a model that is able to achieve the required fidelity and to find or develop a hardware that is able to bring the queues up to the level of fidelity that is required. If this is doable, maybe with some iterations, we can go and perform the flight simulator test. Perform the test. Of course, we will get some validation comparing what we do with flight test data or the available flight test data. And then we will eventually produce documentation or output that could be used for the certification of the aircraft. This is just a brief overview of the schedule. We just started in June 2019. So right now we are entering into the crucial part of the project, that is the phase 2, and we expect to finish and so to complete the work at the beginning of year 2022. The phases, we are planning to, we plan to organize the project in 3 phases. So in the first phase, that is the one we are completing now, we engaged EASA, so as a certification authority, and industry, and in this case, the industry was Leonardo, to define a list of certification topics that are of interest and that are, of course, suitable to be performed by simulations. Then we will start the second phase where we'll really have to do the work of definition of metrics, both for perceptual fidelity and for models, to understand what are the capability gaps in terms of capability of modeling and capability of delivering the right cues in the right simulator, and try to fill the gaps and develop models that are appropriate for the task. Then in the third phase, we will try to apply the scheme, and so try to develop some certification tests in a simulator using a newly developed simulator at Leonardo plants. And we will deliver the guidelines out of the experience we gained in this third phase. So of course, we are not talking about nothing new. I'm quite sure a lot of applicants are already using simulation in some cases. The typical cases where you use simulation right now is when the flight demonstration is too risky, and in this case there is probably no other choice. The second case is the cases where the environmental conditions are too difficult to attain, or cases where you need to have repeatability and demonstration of a specific scenario with a range of pilots. So the idea we have is to extend the application of simulation out of those 3 cases to more general situations, because we expect that applying flight simulation will clearly improve safety. The simulation can anticipate risks, anticipate problems, reduce risks, and prevent risks in some cases. Additionally, simulation will bring the costs of certification down. Flight tests, are expensive. They require time, they require a lot of people. And so simulator can really reduce the costs. Also, there is no risk to damage the aircraft, as there is in some cases during flight testing. Also, the duration of a certification campaign could be significantly reduced, going to a fraction of time of what is required by normal flight tests. Just to give you an example, environmental condition can be easily adjusted in a flight simulator, while when you have to perform a flight test, you have to chase the right place and the right condition in order to perform the required test. Finally, we expect flight simulators to be more effective, allowing higher repeatability of the tests and possibility to easily certify slight changes of configurations using the same simulator. Of course, there are challenges, and the first probably major challenge here is extrapolation. This is taken from a guideline developed by FAA for fixed-wing aircraft, and they say the simulation should be suitably validated by flight test data for the condition of interest, but this does not mean that there must be flight test data at the exact condition of interest, because if you fly that condition, there is no point in doing it by simulation. So you definitely need to validate your model, but then you need to test it out of validation points. So you need to extrapolate, and you need to rely on the right physics modeling of your system in order to be sure that what your simulator is showing is reliable and is representative of what the aircraft is doing in that condition. And so the second challenge that is related to the first one is really to develop a good credibility of the models used. And credibility means to reach a level where the user can say, I believe the simulation is credible and I'm comfortable in taking the needed decision with it, so with simulator. Because if I have to go and fly the test again, there is, again, no point in using the simulator for certification. So there are typically three elements that have to be considered when you perform a flight simulation. One is the pilot, of course, and the other two are the fidelity of models, and this is predictive fidelity, and here we talk about fidelity of the aircraft and fidelity of the environment and external disturbances, and the perceptual fidelity that is related more to the hardware used for the flight simulator, and so related to the cues that are given to the pilot in order to perform the task. Simulators are, they are quite used, but basically in the majority of cases right now they are used for training. So there is a lot of work that has been developed, and part of it is included in the FSTDH related to how to evaluate the quality of the simulator. But this is developed for training. Here we have a different objective. Again, we have to rely more on extrapolation, so probably we will need to develop a different type of simulators with different metrics to evaluate them, because those are not training simulators. So one of the goals of RoCS is really to define a standard to characterize those simulators and to understand what is really important and meaningful in a certification simulator. Regarding the modeling side, we already identified some gaps of the modeling, some challenges that have to be tackled. Clearly, interference, aerodynamic interference is one. You need to find a good agreement with models, and you need to find models that are not too demanding in terms of computational activity, otherwise they will be not functional to a flight simulation in real time. High-speed dynamic stall is another aerodynamic problem that can affect performances in some cases, and it is very difficult to model right now. And other elements that could impact the response of the helicopter could be related to blade flexibilities or in general aircraft flexibility. So those are clear challenges. The other challenge is the interpolation, the prediction. Because typically when you develop a model for a training simulator, you already have your validation point that are filling your operational envelope and or your normal envelope, and you interpolate between them. In this case, we will go outside the envelope of validation points, so we will need to perform a prediction, and we will need to extrapolate the models up to a point where we do not have a validation data. So we need to evaluate the predictive capability of our models. In this case, we are planning to use uncertainty quantification and sensitivities in order to understand what is the maximum error that we can expect out of our model and compare the maximum error with the allowable prediction error, where the allowable prediction error is the distance between our model and the boundaries of compliance. So if we are well within the boundaries of compliance, we can clearly state that the model is reliable enough for doing the job for whom is developed. Other works that have to be performed are related to development of test procedures, development of appropriate metrics for queuing, and in some cases we will have to develop new metrics because again the objective is different, and the final work will be the performance of a certification tests in Leonardo Simulator. So we are planning to build within the project a new simulator that will have the characteristics required to be a simulator for certification. So we will try to limit on the modeling the non-physical tuning of the models. Again, we will have to rely a lot on extrapolations. We will try to limit as much as possible the relevance of pilot evaluation in adapting the models to pilot evaluations, because again, if we adapt too much the model with non-physical tunings, we lose the possibility to have a reliable model for certification purposes of the aircraft. And one other aspect is to develop a flight simulator that is low cost. Because again, if we bring the cost of the simulator to a very high value, then again, there is probably no value anymore in using simulation instead of going and flight tests, especially if the simulator has to be exactly tailored on your helicopter. And this means that you have to develop a new one for a new helicopter, and so on and so forth. So we already performed the first analysis of the CS. And so I can anticipate that those four indicated here are going to be the main scenarios where we will apply our approach. The first one will be the analysis of Cat-A maneuvers, and in particular rejected takeoff. The second one will be related to low-speed controllability, in-ground effect and out-of-ground effect, especially the idea of extrapolating in altitude. The third one that we will tackle will be dynamic stability, both in VFR and in IFR conditions. And the fourth one will be related to tilt rotor, since the whole goal of the project in the end is to develop procedures that could be applied for the certification of the next generation tilt rotor, will be related to power of landing and AFCS failures that are a major certification problem when you talk about fly-by-wire aircraft as a tilt rotor. Regarding the expected impact, we expect to decrease, of course, the risk, to promote a better knowledge of the rotorcraft characteristics, to reduce costs. Potentially, we can reduce the cost of flight case campaign by 90%. So there is a high potential here that is justifying the investment. And of course, also there is the potential to reduce the time required to complete a rotorcraft certification, and so the time to market of a new product. And again, think about the effort required to bring to market a tilt rotor. Last word about dissemination. We are planning to have a showcase workshop at the end of the program, so in 2022. There will be, we will ask stakeholders to participate, and the workshop will allow the stakeholders, pilots, manufacturers, to participate in a demo a simulation test for certification. So I ask you if you're interested to check the website and send us an email so that we'll know that you are interested in participating to this workshop. And we expect also by the end of 2020 to perform a consultation with the stakeholders of what we are doing and to get a feedback from the stakeholders. So please, again, if you're interested in this effort, check the website and let us know if you are interested. Before closing, let me acknowledge all the partners of this project. So together with Politecnico di Milano, we have two universities that are University of Liverpool and Liverpool John Moore universities. We have two research centers, NLR and DLR, that are working with us, and we have a small SME company in Italy that is called GA that is working on the development of the hardware for the flight simulator. And then, of course, we have Leonardo that is the topic leader and that is providing us expertise, information, and data for models and certification tests, and EASA that is guiding us in this effort. So thank you very much for your attention. Let me acknowledge the European Union that is giving us the funding, and Clean Sky joint undertaking for allowing us to work on this subject. Thank you again.